Greetings, Internet users. When night falls in a clear sky, tiny dots of light, usually whitish in color, appear and fill the entire firmament. They are the stars that fill our galaxy. In fact, there are more of them than we can see. Those tiny points of light that seem identical are not. Many types of stars are born from the interstellar medium. Many of them host planets, and in their final stages, they will destroy those same worlds they created. Some will become black holes, and others will become a planetary nebula. Today, we will talk about how different types of stars are born, how long they last, if they can all host planets, and what will happen in the end of their days. How does a star form? In the interstellar medium, there is a great amount of dust and gas. In this medium, there is a lot of hydrogen, at least 91%, followed by helium, and in smaller proportions, other heavier elements such as carbon, oxygen, and nitrogen. This is called stellar metallicity. In molecular clouds, the gas is usually uniform and can be affected by different factors. The expansive waves from a nearby supernova can fragment the cloud, giving rise to denser cores. Traveling through the galaxy's spiral arms can also fragment the molecular cloud in different locations. More gas will accumulate in these dense cores, with temperatures reaching 263 degrees below zero. The gas and dust will continue to concentrate in these dense cores, increasing their gravity and attracting more material. As it attracts more material, the temperature will rise. The increasingly crowded hydrogen and helium atoms will create a protostar, forming a rotating accretion disk around it, which can eventually give rise to planets in the future. Gravitational collapse continues for tens of thousands of years, gaining more mass and temperature. It becomes a voracious baby star, and the excess material is expelled in large jets. After the infant stage, it reaches stellar adolescence, still very active. This is when the conversion into a compact star begins. When the core is dense enough, atoms start fusing, forming heavier nuclei, and releasing energy in the process. The star increases its brightness, hydrogen begins to convert into helium, and nuclear fusion begins. A star is born, a sphere of plasma that releases a great amount of energy for most of its life. Stars in their adult stage fuse hydrogen, converting it into helium in a stable manner. This is known as the main sequence. Nuclear fusion allows the star to avoid collapse. The intense gravity of the core tends to compress it, while the energy produced by fusion expands it. Depending on the amount of material in the stellar medium and the fragmentation of the initial molecular cloud, stars of low mass or high mass can form. Giant stars are generally found throughout the universe, and they often form in groups. The Sun, as a solitary star, is not common. Sometimes, there is not enough material for a star to form, and it remains in an intermediate state. This is the case with brown dwarfs, which do not reach the necessary temperature in their core to initiate nuclear reactions. They are also called failed stars and emit such little light that they are invisible to us. They can only be detected with sophisticated instruments. It is believed that brown dwarfs are rich in lithium, which can be detected. If Jupiter had about 12 or 13 times more mass, it would have become a brown dwarf with a temperature ranging from 800 to 2000 degrees Celsius. Red dwarfs are the most numerous low-mass stars that exist. It is believed that they represent 85 to 90% of the stars in the Milky Way. They are invisible to the naked eye, and we can only see some of the closest ones with telescopes. The galaxy is truly filled with them. As we increase in mass, we encounter stars like the Sun, which are uncommon. Some of the closest ones can be seen with the naked eye. Then there are massive stars, which are quite rare and visible to the naked eye. When you observe the night sky, you must think that almost all the stars you can see with your eyes are massive stars. Imagine the number of stars you are missing out there. The Monoceros or two-molecular cloud is a gas region located about 2,500 light-years away, where stars are forming. It's a stellar nursery. How long do stars last? The lifespan of a star is related to its mass. The more massive it is, the shorter its lifespan, as it consumes fuel more quickly and shines brighter. The less massive a star is, the slower it will consume its hydrogen fuel, resulting in a longer lifespan. Some stars can last longer than the age of the universe. For example, low-mass red dwarf stars like Proxima Centauri, which has a mass about 40% lower than that of the Sun, can surpass 75 billion years. As we increase the mass, the lifespan of a star decreases until we reach solar-type stars, which typically live between 10,000 and 12,000 million years. The Sun, for instance, was born about 4.5 billion years ago, so it is reaching the midpoint of its life with a little over 5 billion years remaining. Massive stars like Spica, a blue spectral type B star with 7 solar masses, can live for about 100 million years. The most massive stars of all are extremely rare and can have more than 40 solar masses, such as NML Cygni, a red hypergiant with with a lifespan not exceeding 1 million years. The formation of planets around stars depends on the molecular cloud from which they formed. If there are enough heavy elements for their formation, known as metallicity, planets can form. However, exoplanets have also been detected in low metallicity systems, although it is believed to be less common. Generally, almost all stars form an accretion disk of dust and gas during their formation, which rotates and gradually forms clumps. Due to gravity, these clumps form larger bodies called planetesimals, a process that takes about 2 million years. The final planets usually take between 10 and 100 million years to form. In these early stages of planet formation, solar systems are chaotic, and many planets change their positions until the system becomes stable. The remaining mass is expelled outward by the stellar wind, forming Oort clouds, minor bodies, and remnants of the planetary formation. It is highly unlikely for the most massive stars, especially hypergiants, to have planets, as they do not last long enough to contain a planetary system. Considering that most stars in the galaxy are low mass and that systems are becoming more metal-rich over time, a significant portion of them will have planets. However, it will take much more time, several billions of years, for the formation of planets with life. This allows enough time for life to evolve, and this generally corresponds to low-mass stars. As for Sirius, which is the brightest star in the sky, we can deduce from its metallicity and age if it is a good candidate to have planets or some form of life. Sirius has a metallicity similar to that of the Sun, although its iron content is much higher, believed to have been transferred by its companion star, Sirius B, which is 230 million years old. From this, we can deduce that Sirius has had time to form very young planets, some of which may be rocky with large iron cores, similar to Mercury, and may have thick and heavy atmospheres, some of which will be swept away by intense ultraviolet radiation. However, it is a poor candidate for life. It is unlikely that any form of life has evolved in a short time. Most planets around stars cannot be detected since our technology tends to discover very massive and short-period planets. The most interesting planets are probably still out there, waiting for us to discover them. How do stars die? The fate of a star depends largely on its initial mass. When nuclear fuel runs out, stars tend to lose the balance between gravity and nuclear fusion. Ultimately, gravity usually wins, and the star collapses onto itself. The mass of that core will determine its possible fate. Less massive stars end their lives more quietly, while more massive stars tend to end in a violent explosion or become black holes. Stars with a mass of 0.4 times or less than that of the Sun, such as red dwarfs, will end their days very calmly, gradually fading away over billions of years, eventually becoming a black dwarf. Those with masses ranging from 0.5 to less than 9 solar masses will expand into a red giant, shedding their outer layers to form a planetary nebula, and ultimately ending as a white dwarf. In other words, the Sun will not explode but will end as a planetary nebula and a white dwarf. However, during the red giant phase, the closest planets will be engulfed and destroyed. Stars exceeding 9 solar masses but falling below 30 end their days in a supernova explosion, resulting in a neutron star or pulsar, which can possibly destroy all the planets in their system. The violent explosion of a supernova can also pose a threat to the life on other planets within several tens of light years due to radiation. Finally, there are the most massive stars, those surpassing 30 solar masses, which end in a hypernova explosion with dangerous bursts of gamma rays. The core of the resulting object is so dense that it curves spacetime and forms a black hole. However, this can change in some cases if there are companion stars that accrete their mass, eventually merging with them. Rotation and metallicity are also factors that can alter the final destiny of a star. Stars live much longer than the lifespan of a human being. It has taken many studies over generations and various types of stars to determine their nature, lifespan, and ultimate fate. Fortunately, we find them in the millions, like beacons illuminating the cosmos, and they are the sources of the matter in the universe through nuclear reactions in their cores. Our origins truly come from the stars. If you enjoyed this video, please give it a like, don't forget to subscribe, and leave your comments.